Hello students! Today we are going to explore the fascinating world of physics and dive into Newton's three laws of motion. These laws are essential principles that govern the behavior of objects in motion, and they can be seen in various systems in our everyday lives. Let's start by discussing Newton's first law of motion, also known as the law of inertia. This law tells us that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. Think about when you're riding in a car, and the driver suddenly hits the brakes. You feel yourself lurch forward because your body wants to keep moving at the same speed and direction as the car. This is a perfect example of inertia in action. Next, we have Newton's second law of motion, which is all about force and acceleration. This law states that the acceleration of an object is directly proportional to the force acting on it, and inversely proportional to its mass. In simpler terms, the more force you apply to an object, the faster it will accelerate. This is why athletes push themselves harder during sports activities to increase their speed and agility. Moving on to Newton's third law of motion, also known as the law of action and reaction. This law tells us that for every action, there is an equal and opposite reaction. This can be seen in activities such as rocket launches, where the rocket pushes against the ground with a force that is equal and opposite to the force propelling it into the sky. Now, let's explore how these three laws of motion act simultaneously within various systems. Take vehicle restraints, for example. When you're driving in a car and suddenly come to a stop, your body continues to move forward due to inertia. The seatbelt then applies a force to your body, preventing you from flying through the windshield. This force is directly related to the acceleration of the car as described by Newton's second law.
First of all, what went through my mind is how stupid am I to actually
In sports activities, such as kicking a soccer ball, you apply a force to the ball that causes it to accelerate and change direction. This force is equal and opposite to the force the ball exerts back on your foot, as described by Newton's third law. These laws work together to explain the complex interactions between objects in motion. Amusement park rides also demonstrate Newton's laws of motion in action. For example, when you're on a roller coaster, the force of gravity pulls you down the track, causing you to accelerate. This acceleration is directly related to the force of gravity and the mass of the roller coaster car, as described by Newton's second law. In Earth's tectonic activities, such as earthquakes and volcanic eruptions, the movement of tectonic plates is driven by forces deep within the Earth's mantle. These forces cause the plates to shift and collide, resulting in seismic activity. This is a perfect example of how Newton's laws of motion apply to large-scale geological processes. Lastly, let's look at rocket launches. When a rocket is launched into space, the force of the engines propels it upward, overcoming the force of gravity pulling it back down to Earth. This is a perfect example of Newton's third law in action, as the rocket pushes against the ground with a force that is equal and opposite to the force propelling it into the sky. In conclusion, Newton's three laws of motion are fundamental principles that govern the behavior of objects in motion. By understanding how these laws apply to various systems, we can gain a deeper appreciation for the world around us and the forces that shape it. So the next time you're riding in a car, playing sports, or even watching a rocket launch, remember the timeless wisdom of Sir Isaac Newton and his groundbreaking laws of motion. Thank you for joining me today, and I'll see you next time.